Hello, Mike Dudley, here to talk about milling operations and continue in Chapter 2. Some of the learning objectives for this presentation is going to understand reasons for milling. There are multiple reasons we may end up milling a road prior to doing an overlay or doing maintenance on a pavement. It can be to maintain a certain grade, it can be to remove some failed pavement, anything like that. And we'll cover some of those in this presentation. We're going to identify impacts of the milling equipment speed and the quality of the teeth. Obviously the teeth wear on a milling equipment quite a bit, and you want to keep them as sharp and fresh as possible. Then we're going to recognize some impacts of the mill depth on the quality of the finished riding surface. Start with milling, which is also called cold planing, can be used to, as we stated previously, remove deteriorated pavements. You can see that in the picture here on the left. This pavement is obviously got some cracking going on. It's hard to see at this angle. It may have a little bit of rutting. You can see the changing color there, but you wouldn't want to lay a new pavement over this surface, as that cracking would reflect through the new pavement quickly. So it's important when you have a deteriorated pavement to remove this prior to adding an overlay. Some cases we want to maintain the existing surface elevation or improve a roadway cross slope. The picture here on the right, if you look about 2/3 the way down on this asphalt curb, you'll see there's a drop inlet. Well, if you came in and just put an overlay on top of this, you close that drop inlet completely off. So in order to maintain the proper cross slope and elevation, you'll need to mill so that the new overlay would tie into that drainage drop inlet. Another reason could be to remove high points in an existing surface this would be done in lieu of placing a leveling course. This again ties in with maintaining the proper cross slope of a roadway. So what do we do with the millings? Millings, which is also called, once you've done the milling operation and you have your millings, which is also called recycled asphalt pavement, or the acronym RAP, is typically returned to the asphalt plant. Millings, once they're returned to the asphalt plant, they can be processed. Once they're processed, they're used in new asphalt pavements. In Virginia, we have anywhere from 10 to 15% RAP put in our SMAs commonly, to as much as 40 and 45% going in some of our base mixes and other mixes. So we have a wider range of quantities of RAP that's allowed to be used in our new pavements. Here's just a diagram of a milling machine so that we can cover some of the components that are part of a milling operation. First one on the left there is the track. So you can see there's 2 tracks underneath this. Notice that paving milling equipment is almost always from tracks because of the weight of a milling machine. Rubber tires just wouldn't be practical, and they would also have too much flex to them when you're trying to mill a certain grade at all times. Next is the center of this piece of equipment is the cutting drum. That's where the teeth, that's the meat of the operation. It's where everything sort of rips the existing pavement apart and brings it and helps to, from there, it's transferred onto a couple layers of conveyors, which will help transfer the millings from the pavement itself, the roadway, up into the back of a truck for transporting to the asphalt plant. Here's a nice picture of a cutting head or a drum. You can see the teeth on here that are used to basically do the actual milling itself. Also notice in between some of these teeth are a couple paddles. These paddles are what help push the millings as they're ground up and processed up onto those conveyors to help you transport it, as you can see, from the roadway to the truck, which is in the picture on the right. That's how the material is processed over. All milling equipment will have some sort of dust suppression system. Typically this is just water. Sounds fancy to say dust suppression system. But it's a combination of this and a vacuum system. The purpose of this, when you're adding water, isn't to create a slurry or to make the road really damp or wet. You don't want any kind of standing water when you're done. You just want enough water to be sprayed into the operation to keep it cool, because the milling operation generates a tremendous amount of heat, and to suppress any airborne dust that could happen during the process. So it's a very mild amount of water. And as we said, the conveyor is what's used to move the material from the roadway up to the bed of a truck. Here's a couple pictures of different milled surfaces. The one on the left is a traditional milling head. That's the milling head you saw in the previous slide with the teeth spaced out and a nice pattern there you saw previously. But the picture on the right is what we call a performance milled surface. And we're beginning to see a lot more of these performance milled surfaces in Virginia, because we're fortunate that Virginia offers ride bonuses a lot on their primary and interstate pavements. And what you want to do is in order to get the smoothest ride possible, you want to be placing on the smoothest ride you can and left over from the milled surface. So these performance milled drums work well. As far as the drum size, the diameter and width, they're the same on these that would generate these two differences. The difference in the performance milled surface versus the traditional milled surface is the amount of teeth. The performance milled surface would have probably 3 times as many teeth on it as a traditional milled surface was shown before. Oh, scabbing. What do you do if you get scabbing? What is scabbing? Scabbing is where when you've done your milling operation and you look back, and here's a perfect example in this picture, and you see patches where it's not same uniformity all the way across. You see a milled texture on a lot of this roadway, but you see other areas that are very smooth. Basically, that's where you can tell there's an overlay been placed on this pavement before. Maybe this overlay was at 2 inches, and this new maintenance operation coming through here is only milling 1.5 inches off. Well, in this case, it looks like that last 1/2 inch in some areas has debonded and broken away. This creates uneven texture that you do not want a placement on. There's multiple reasons here. If it debonded in those locations, odds are there's other locations that are still stuck down that are also weak, and that could create a premature failure in this pavement. So the best scenario and the best way to handle for long-term performance of this roadway is to drop back and maybe move more, mill a second pass to get it more uniform before you do any kind of overlay. After the milling machine has gone by, it's very critical, it's crucial that we actually clean the surface. The next process in a paving operation after milling is to be tacking before we do our overlay. If the pavement is left behind, has a lot of dust or debris left on it from the milling operation, not properly cleaned, the tack will adhere to that dust and not to the pavement that you're getting ready to apply your new asphalt pavement on. So it's important that we clean this surface as clean as possible. This can be done through multiple ways. You see here in this picture, they got a brooming operation going and a vacuum operation in the middle of it. So this is a combination of vacuuming and brooming. Other options could be to just flush the pavement with water. One I see done a lot more and I think works really, really well is to just open the pavement up to traffic and let the traffic clean your pavement for you. If your particular contract allows you a time between the milling and the paving operation, let the traffic do the work and save you the time and effort. In summary, milling was short. First step of most paving operations, or at least many paving operations, is the milling. And that's to remove any deteriorated pavement and make sure that when you apply your new layer of pavement, you're going to get the maximum life out of it. Milling quality will impact the ride and the density of the pavement you lay. We saw on that scabbing pictures there that if that wasn't removed and done properly, you would get different densities in areas where the pavement that you're applying your new surface to are uneven. So it's important that part of what the milling is doing is making a very even, uniform surface for us to apply our new pavement to. We talked about how critical it is that the tack bond to the previous road surface so that it doesn't stick to any kind of dirt or debris left from the milling operation that wasn't properly cleaned up. And as we stated about RAP, the recycled asphalt pavement, asphalt is actually the #1 recycled product in the world over any kind of plastic, any kind of glass, anything we all recycle in our homes, but actually asphalt is the #1 recycled product in the world. One other thing I want to mention to everyone, we have some extra presentations available in Canvas or on YouTube, and I want to point them out in this presentation. They really go into a lot more detail. These are online only, and they come from what we call subject matter experts, the people that make the milling equipment and can really explain the options you have with this and the different things you can do with it. The first one is from Cal Hammond from Road Tech, and there's a second one from Tom Chastain from Work in America. I highly, highly recommend both of these presentations and ask you to take the time when you have time available to you to look through these presentations. And if you have any questions, please direct them to your facilitator or proctor in your classroom.